sure why I'm in a bad mood. Maybe the Celtics lost their last game.
Yes.
Oh, really?
Yeah.
No,
No, I'm just saying I was in a bad mood. You want to put me in a worse mood? Is that a good idea?
He's gonna walk back there and,
All right. So 15, what is the easy equation I could set up here?
X plus Y is equal to 9.
You guys see that? If this is the amount of this one, this is the amount of this one, how much total do I want to end up with?
9.
9. So obviously, you always have one equation that's relatively easy. I mean, this is, add them together, I got to get 9, because I want to end up with 9 gallons of this stuff. Holy crap. Right? I'm not sure what I'm going to do with it, but somebody should keep an eye on me. Now, the other one is really a lot like the one we just did, the interest one. The other one is the same way. I want to end up with a 30% solution, right? That's what I want to end up with. So, how much alcohol is in this?
0.20x.
So, like if X were 30 gallons, how much alcohol would there be in there? 20% of 30, right? You guys with me? How much alcohol would be in this one? 50% of whatever. So if I had 10 gallons of this, that's 5 gallons of pure alcohol, right? Cool. So if I take 0.2x, the alcohol in this, plus the alcohol in this, I got to end up with the alcohol 30% in
of 9 gallons.
the total. That's how you set up a mixture problem, right? So you have one idea which is purely an amount idea. The amount plus the amount equals an amount. And that's a really cool check. You can just take a second to make sure, are these all the same thing? So this is alcohol plus alcohol equals alcohol. If you only put that, it doesn't make a damn bit of sense. Alcohol plus alcohol equals percent. No. I need 30% of 9. I need to have everything represent the same idea.
So now you just substitute.
Now I can substitute. Now if you wanted to, you can solve this for y and plug it in there, or solve it for x, I don't care. Or you can do elimination, right?
Yeah.
If you wanted to, you can multiply this one by 10 to kill the decimals, and then multiply this by -2 to kill the 2x.
Yeah.
You guys kind of see where to go from here?
Yeah.
Cool. That's a classic mixture problem, right? Very often you see like a saline solution. Anybody interested in nursing? You want to get a certain saline solution, and the doc says you need 5% saline solution, and all you got is 10% and 1%. Well, you got to know how much of each to mix to get what the hell the doc said he wants, or else you're out, right?
you're fired.
Yeah. So you guys, that's what I set it up, so you guys can finish that out.
18.
We just keep moving here on the same thing.
18. Read through 18 for a second. This is all about Paul and his nuts and oats.
No, I have no problem.
Hey, no problem?
Sorry, sorry. I have no problem.
Oh,
See, she was making you say
yes. All right, real quick word on 18. Guys, stay with me now. 18. Look at 18 real quick. You see what is it that I don't know in 18?
How to do it?
Okay.
that too.
How to do is pretty easy, just mix them. What is it that I don't know? How many unknowns do I have? 2. What are those?
Oats and
Yeah. The amount of oats, and the amount of nuts,
Yeah.
right? So then what's x plus y, for example, got to be?
25.
25 pounds. I want to end up with 25 pounds. You see how it's exactly the same problem as this?
Right.
Except instead of percentages, they give me price per pound. So and not a 0.2x here, but it's going to be like a 1.55x there. Do you guys see that? $1.55 per pound. Plus $1, let's see, $1.35 per pound, thank you, right? Equals $1.45 per pound, so times 25. It's exactly the same as this. Because what kind of problem is it? It's a mixture problem. It should be exactly the same as this. Here it's percentages, there it's price per pound. It's the same idea. Because this is really 20% alcohol per gallon. So it's the same idea, it's a rate. So in number 18 it would look like X is nuts, Y is oats, X plus Y has got to be the total. And then you got a money equation, right? So it'd be a dollar, like we said, $1.55.
A dollar.
X plus, you guys can set that up. It's the same exact setup.
Equals 125 times
Yeah.
145.
So it'd be plus what is it, 135?
Plus,
Y? Now, and see how this makes sense? If I mix some more expensive stuff with some cheaper stuff, the result should be in the middle of those, right?
but then you, like you said, you times it by 145.
Yeah, so I want to end up with $1.45 a pound
Times 25.
times 25. Now, based on what I said before, do you guys notice something about $1.55, $1.35, and $1.45? I want to see if you guys realize this. Like we're talking about before.
Yeah.
Isn't $1.45 right in the
Middle.
middle?
Yeah.
So I'll bet you anything that I want how many pounds of nuts and how many pounds of oats, if I want 25 total. How much of
75 and
each?
25, 145.
The same.
145?
12 and a half.
For each one.
Yeah.
I want 25 pounds total, right?
Yeah.
And the only way to make it average out what there is to have equal amounts of both.
Yeah, number of pounds.
Now don't think, oh cool, let me just put 12.5 down and I'm done. No, do the work, but now you know what to expect. If you don't get 12.5, you did something wrong. Why do you know 12.5? Because it makes physical sense. The only way to take more expensive stuff and mix it with cheaper stuff and get it right in the middle of those prices is to take equal amounts of both, right? We're going to assume whoever's doing this is honest and isn't going to put some more cheap stuff in there like diluting gasoline, right?
So on
I
that,
don't have to be
on that
concerned
first one,
about
to eliminate X, you put a negative 155. Then eliminate that.
Yeah, now you can do substitution, you can do elimination, whatever you want to do.
Jeff, I have one more quick question on 4.1, and that was on number 45. Because I cannot find anything to cancel.
For 45?
Yeah.
Oh, we did 48, I think, last time.
Oh, we did?
And 45 is basically the same. You're going to get ugly numbers. There's just no way around it.
Yeah, I can't find anything to cancel out. That's the only thing that is.
Oh, no, wait a minute. So you're not sure where to start?
Yeah, that's the only thing.
Section 4.1,
Hideous fractions.
number 45. Stay with me now. Now, that's a suggestion. What might be a good variable to eliminate here?
X.
Why?
Elimination.
I love it. We got X and Y. Well, I mean, to me personally, I would choose these because they happen to be opposite signs already.
Right.
And if I start multiplying by negatives, that opens the door for me to make a negative mistake, right? Now, if this was 8, I don't care that they're both the same sign then, because then I only have to multiply one of them by something, right? Because the 2 can become a negative 8. But here I got to multiply both, here I got to multiply both. I might as well take the ones that already are opposite signs.
Right.
So what would I multiply the first one by? And remember, this is just like LCD.
Yeah.
What's the LCD of 1 over 8, 1 over 3? It'd be 24. So multiply 1 by 3,
And then
Oh, okay, so you just have to multiply
right? And
both
if you want to, you
equations.
put 3 next to everybody. Maybe your 3's look like 3s, I don't know. And then 2, multiply by what?
By
By 8. Because they both need each other.
16,
right?
okay, so you multiply both equations.
Yeah.
Just so stupid.
No, that's all right. I mean, you get into the role, you get it used to not having to, only have to multiply 1, and then they
Yeah.
throw this one at you.
You're just like,
But it's like an LCD idea. Raise them both up until these go away.
okay,
that gives you X.
Yeah, so I'll let you guys finish that on now. You're
okay,
almost there
that's
anyway.
good.
Cool. I love watching you guys because I can tell who hasn't done this homework yet. 'Cause it's like, okay, there's one that's almost done. All right.
Total confidence builder, Jeff, thanks. Total confidence.
He knows, he knows.
We're not gonna take notes.
He knows.
Which day?
Which one?
You've been doing this too long, Jeff.
3, 4, 7.
No, I'm always optimistic. I like to say I'm an optimistic fool, but I understand the reality.
Whatever you say, man.
What are we working on now?
This is page 347, number 24. It's the last question I'll take. We got to get into some more stuff.
I'm sorry, from which section?
4-5. Right, the one about the airplane? Right? Okay. So an airplane covers a distance of 1,500 miles in 3 hours when it's with the wind. And 3 1/3 hours when it's against the wind. Okay, so 1,500 miles and 3 1/3 hours against the wind. Okay. Let me show you something kind of cool in this problem specifically, because the problem with this one is not knowing what to do with what they give you. Well, what's the main equation relating distance? Rate, which is what I don't know here, right?
Rate and time.
And time. What's that main equation?
GRT.
D equals
Equal RT.
RT. Dirt. You remember that, yeah? Right? So, actually, let me see if we can get away without this. How many things do I not know in this equation? They might...
The rate, the speed.
Speed of what?
The wind.
Speed of the.
Speed of the wind. So let's say X is the... We can say W, but let's say... Yeah, let's say W.
Speed of the.
W is the speed of the wind.
Speed of the plane.
And the speed of the plane.
We already know the speed of the plane is going 500 miles an hour, it's going 1,500 miles in 3 minutes.
With the wind.
Okay.
So that's the speed of the plane plus the wind. See, now that's where an equation's going to come from, isn't it?
So it'll be.
Because the wind's going to increase its speed, so you're going to have to figure out by how much.
So
it's
let's
increasing.
say, I don't know, A is the speed of the airplane.
And then W.
Exactly. W is the speed of the wind.
So you have to figure out
So
how
W
much.
plus A equals, what?
Now be careful now. Use this equation twice, right?
Yeah.
Because it gives me two situations.
W plus A equals 15.
So one, how far?
1,500.
1,500 miles.
Yeah.
Equals,
What's the rate
we don't know.
with the wind?
3 out
X minus Y.
X minus.
Careful now with the wind. If my plane goes A miles an hour and the wind is going W miles an hour, I'm going with the wind.
You're going to multiply
I'm
it.
going faster.
A times W.
Not multiply, or else people
Add.
are just shooting out into orbit. That's
A plus
a
W.
little bit of wind, we're like, what?
A plus
So,
W, right?
Yeah, so it'll be, the rate here will be A plus W. And what's the time?
3 hours.
3 hours.
I want you guys to see that. So it goes 1,500 miles,
In 3 hours. With A plus W.
going this fast, because it's with the wind, right? With the wind,
Multiplied by 3 afterwards.
in 3 hours. Cool? So sure enough, when you start to solve that, you can divide by 3, and there's your 500. I love it. Right?
So is that the answer?
Well, that's one equation. How many unknowns do we have in there?
2 of them.
So I need one more equation, so thank God they gave me one more situation, right?
55.
A minus.
So it goes 1,500 miles,
A minus.
A minus W.
A minus W, because now it's against the wind.
And then multiplied by
If I
3.
go A by myself and the wind's pushing against me, now I'm going A minus W.
And then it's times 3 1/3.
Times 3 1/3.
Can you do
exactly.
3.3? No.
Or you can go 10 over 3.
I love it, or 10/3.
Is that the same of upstream and downstream?
Same idea as upstream, downstream. Because water is just a more solid thing. It's liquid instead of